With SouthCoast Mechanical, we were the subcontractor working under H.C. Olson for this project. Basically, there's three pieces of equipment out there. We got the open loop, open cooling towers, Marty cooling towers. We have the Dawson VSX pumps and the Danfoss drives. And we'll get into the nuts and bolts of the equipment. I have Matt with Dawson. He's going to be going through the pumps and the PMs on the pumps. We have Larry and Spencer with Marley Cooling Towers and DMG. They're going to be talking about the open cooling towers. And we also have Adrian, the service tech, with SouthCoast. He's going to be talking about any questions with the Danfoss drives. With that being said, probably short and sweet. Mark's a hard act to follow, but I'm going to bring up Matt with Dawson, and he can go over the pumps.
I'm just going to take this off. Okay. Hi, I'm Matthew Freer. I'm with the Dawson Company. We're the manufacturer's reps locally for Bell & Gossett pumps. Today I'm here to discuss maintenance on our VSX type pumps. And nothing, of course, that I state today overrides what's in our installation and operation manuals written by Bell & Gossett. Today we're going to discuss maintenance and things to be looking at on the pump to make sure that it lasts the life of the facility, because that's what we do. We build our pumps for the life of the facility. Right here on our picture, I'm just going to use this one picture because it's very simple and showing what's on the pump from basically left to right. Starting with the left side of the pump in the red is the actual pump portion of this. On the right side is the motor portion of it in gold. Between the two, we have a coupler that connects the two together. That is a rubber style coupler that allows some flexibility in there. And then working our way from the pump across here, we have mechanicals that we need to identify. We have our bearings and seals on each side of the pump, the bearing and the seal inside of there. This pump is designed to be maintained by one individual. You don't need to take it too far apart to be able to access some of the equipment inside of there. If you could turn to page 9 of your VSX handout, there's some nice little pictures here that show how you pull this thing apart. Actually, I think I will switch to a different picture real quick because I want to see the end cap. There we go. Let's take this one. And come up. Okay. This end cap is simply with 4 bolts on there. That 4-bolt pattern allows you to pull it off like any old standard flange. To access the end one, there's no shaft coming out. It's easy peasy. On your inboard motor side, you would have to remove the coupler and disconnect it from the motor to be able to remove that bearing and seal it on that side of the pump. Because there is two. You know, this is a double suction pump, so we have seals on both sides of it. Water flows in, it actually splits into 2 different directions. One goes onto one side, half the water goes onto the other side. This balances out the pump so it doesn't thrust in any direction. Keeps it nice and happy for the life of the facility. Normal pumps like to thrust in one way or the other. This keeps it all balanced. So if you have an outboard bearing going out on it and you can hear it, usually some sort of fluting or some roughness to that bearing, you can literally replace the bearing with just 4 little bolts off the end, and that little end cap comes off. The bearing is internal to that, and you would need to press that bearing in, so you would need some sort of hydraulic press to push that bearing down in there because you can't just do it with your hands. That would be the one major tool as part of this. Behind that bearing, though, is the seal. Seal's very easily accessible, and you can see that in the pictures here. Slides right out. You can slide another one. Those you really generally don't need a tool except for maybe a piece of tubing to slide the seal in square. You know, just don't want it cocked off one way or another. And then those are really your main 2 high fail components as bearings and seals on these pumps. Everything else is almost a non-wear item. It doesn't, you know, rub against anything or have any sort of wearing ability to it. If you ever come up to the pump and you can't get the bearings off the shafts or can't get the seals off the shafts because of water corrosion or something like that, you might have to take the whole rotating assembly out, is what we call that, which is basically the impeller, the shaft, and everything that is actually spinning around inside of the pump. And in that case, you would have to remove all these bolts around the outside. This end cap comes off. These do get kind of heavy. We do put a little thread on the top here so you can put an eyelet right down in there, and if you had a hoist, you can put it off the side if you didn't want to pick it up yourself. But generally, 150, 200-pound guy can actually lift these off the end of it without much problem. I can myself. So that's generally what I do, is I'll just pull it off and set it on the ground right there. And generally these are in a position that you can do that. Once that's removed though, that rotating assembly is just sitting in there. The support of that one end is this bearing out here. So when you remove that, it kind of just falls off, falls down. Inside of the pump will be another set of bolts. You pull that cover plate off. That'll give you access to that internals, and you can slide the whole rotating assembly out of there. Take the shaft, bearings, put them on a press, slide the stuff off, wire brush stuff to get some of that crud that's built up onto there, which is why you can't get it off usually. So it is serviceable. You don't have to take the casing apart other than the end cap. So that makes it easy. A lot of the split case pumps of tradition require you to take the top half of the pump, disconnect the piping, so that you can access all of that internals. With this, you're just taking the end cap off. Of course, on the bearing or the motor side of it, bearings and seals do require, like I said, the OSHA coupler to be removed, and then it gives you access that way. If you do ever have to remove the motor or move the motor, this is where we would require a new alignment to the pump, or a realignment of the pump. Since these pumps are split coupled, go back to my original picture. Which one was it? Oh, it was on there. There it is. Thank you, eBay. There you go. You can see there's shims located under this motor. These shims are used to raise, lower, move this motor around so that we are in a perfect alignment with the pump end. To do the alignment, we don't really require any special tools. I'm going to show you my pump alignment tool. Credit card, business card, any flat piece of material can be laid across the coupler, and you're looking for any sort of misalignment, tilting type of thing. It really just needs to be a straight edge alignment. We don't require laser alignment, dial indication alignment on this type of coupler. If you look in on E on the bottom left-hand corner, this is a new style of Duraflex coupler. Duraflex has been come out for a few years now, and has a bit of an arch to it. Before you put that arch portion on, that's where there's flat portions that you set your card on. And they're basically coupler halves that go onto it. Take a quick gander at that.
So there's tolerances, Mark, Matt, with
It basically looks like two round donuts when those couplers aren't there. Flat pieces of metal. So you can literally check the alignment all the way around on any, portion of that. If you
Coupler split?
Yeah. Yeah, you won't be able to see that in where the split is. They don't show that in the picture. It's probably at 12 o'clock position. We're pointing straight up. But there's two coupler halves. One comes on one side, one comes on the other.
Yeah, that's really...
It's very simple. You don't have to, unlike older couplers, slide a coupler half back to be able to pull it out. The coupler halves stay. You just simply come around. Key thing though, now that we're no longer going inside, in the past we usually just slipped inside and that coupler just stuck in there. There was nothing holding it in other than the fact that the coupler halves are coming over the top of it. With this design now, there's 3 bolts on each one of the coupler halves. Each of those bolts needs to be torqued. And there's torque references in the IO&M that talk about, depending upon the size of the pump that you're dealing with, how much torque that's going to be doing. We recommend that you torque those down after you install them, simply just so that it doesn't fly apart when it starts spinning. Key thing, if you ever do this and you notice some vibration, you probably have one of those coupler halves coming loose, because as soon as it starts to come loose, now you got a wobble. We want those in and tight and around that unit. Very simple though once it's done. You saw those arches in that thing, it actually allows for quite a bit of misalignment and will operate in that mode for a long period of time. I think the manufacturer gives almost an 1/8 inch misalignment on these things. So we don't need laser alignment and stuff like that. However, the more aligned it is, the less flexing it's going to do, the longer the coupler is going to last, obviously. So if you wanted the laser alignment, I have no problem with that. You can do that. Inside of both shafts, when you remove that coupler, what looks to be a stupid piece of rubber is probably the biggest thing that you need to make sure is there. It looks like a washer. And what it is this simply on the shafts going into the motor and into the pump. It's called a water slinger. And if you don't have that water slinger there, guess what happens to the water? Runs on the shaft right into your bearings. So without that there, you're going to lose your bearings, especially in an outdoor pump application, within a month. As soon as it starts to rain and you get some water on the shaft, it's going to migrate its way right into the bearing. With the water slinger there, with centrifugal action, actually causes that thing to fling the water sling off that pump shaft and get it away from the bearing before it gets in there. You can actually see the Baldor one in this picture. It's basically just right there, so if there's any water in there, it'll fly off and blow it away. I've had a lot of people get the brand new pump motor and see that thing on there and think it's part of shipping, pull it off, throw it on the ground, and install the motor. Less than a month later, the bearing on the motor right here is going out. This one's still fine. So keep those on there whenever you do any service. Don't lose them. That's probably a big culprit I find when somebody's just done service and, oh, we already lost the bearing. It was because the week after it had just rained. So that's probably one of the key things. One of the things I wanted to discuss, though, that's specific to this project is NPSH. Some people think NPSH stands for not pumping so hot. NPSH is actually a net positive suction head. And these pumps have a requirement of pressure to come into the inlet of the pump. When I run the calculations, it's about 3 pounds, 2.5, 3 pounds. On the gauge when I was out there the other week, I noticed that it was hovering somewhere between 0 and 1 pound. So it's very, very low. It's nothing to do with the installation. It's simply the way that they design the tower and level to the pump. Higher the tower is, the more NPSH we have coming into the pump. Just simply the water weight of all of that tower coming into the suction of our pump. Because pumps don't suck. They literally produce a differential in pressure. So if we have no pressure coming into the pump, we're going to end up cavitating inside the pump. When cavitation begins to happen, it's going to sound like there's gravel inside the pump. So if you ever walk out there and you think there's gravel in the pump, there's not. What it is it's air coming into the pump and imploding on our impeller. To resolve that issue, shut the pump off, go to a different pump in the system. It might even make the same noise as well. Clean the strainer. The bucket strainers that are out there, once they get filled with debris, will begin to have a pressure drop across them. Doesn't take much to go from 1/2 pound to less than a 0 or below suction or below 0 on that and cause a suction in that line. Once that starts to happen, it will start to tear apart the internal impeller on this. It'll start to look like Swiss cheese. And that's probably the biggest mechanical failure that could happen on a condenser water pump. That can be the most costly and the most difficult to repair, because essentially we have to tear the whole pump completely apart, take all the internals out, replace the impeller in there, and then put it all back together, and somehow figure out a way so it doesn't happen again. So if you ever see that happening or hear that noise happening, I would suggest you alternate your pump, go to a different pump, and clean out that strainer, because more than likely that's what's causing it. When I was out there the other day, there was no issues as far as cavitation on the pump. So it operates, even though it's below the 3 psi that we require of it, it's operating fine within that 1 psi realm. That's perfectly fine. The only way that you will ever get around from this situation is to actually mount the tower up about another 6 to 10 feet. And I don't see that happening. So keep that in mind. NPSH is a critical thing on this installation to make sure that we don't get into a tearing apart of the pump situation. Any further questions on the pumps?
But talk about grease lubrication, greasing.
Oh.
I mean, they are greasable there.
We actually have gone to yeah, they are greasable bearings, but we have gone to a high-grade synthetic grease, quote unquote, good for the life of the pump. If you wanted to, under your annual maintenances, there's absolutely nothing wrong with re-greasing the bearings. The bearings can use the same synthetic grease. You can use your own petroleum-based grease. But if you do the petroleum-based grease, you're going to need to replace that grease every year. You know, it will need to be changed out on a regular basis. Synthetic greases, they tend to last a long time, and we get considerable life out of the bearings with this grease. The zerks that are located on front and back of the pump are usually located right at the top here, and there you can see a little red one right there, to allow you to grease those, as well as on the top of our bearing assembly here, and over here is going to be a zerk for those as well. Water is the biggest detriment to the bearings, not so much the greasing of those bearings. We find more than likely it's water that's destroyed a bearing, or like we had discussed with an electrical issue, destroying the bearing as well. Generally, I don't find an ungreased bearing unless it was a complete maintenance, left the pump sitting there for 10 years and never did a darn thing to it.
Do you recommend adding grease to them annually, or quarterly? Synthetic is good for life of the pump? Or?
I would, to be honest, if this were my pump after about 3, 4, or 5 years, or if you ever lost the bearing, then you know you're probably getting into a situation where you probably want to do it annually. I generally find when they're outdoor like that, I would probably do it annually, just simply from the sun beating on it and stuff like that. It warms the grease up even more than in a chiller room would be, as well as the elements outside. So it doesn't hurt to do, even though it's written in that we don't need to have that done. I would still say it's okay to do.
Spare parts, Matt?
Spare parts, bearings, seals, gaskets. There's a small gasket that goes around that 4-bolt flange. You know, it's not a big deal, but $3, $4. But having a few of those that you can, so when you do that service, you can put a nice gasket on there and it doesn't leak. The bearings and seals that are on these, nothing special. You can get them at Motion Industries, AAA Electric. You know, we don't put anything special that you can't buy from your average parts store when it comes to those items. Now, of course, you need anything painted in red, it's cast by us, you're going to need to buy it from, one of our distributors or from us directly, so that you can get that B&G part. But the high fail components, those are all going to be a standard item, off-the-shelf type stuff from your local distributors. If they don't have it at that location, they'll have it probably somewhere in their group. And then probably the last thing on these things is air. As cooling towers are notorious for getting a lot of air through the pumps. If you ever notice that you're shutting off pumps for extended periods of time, sometimes air will get at the top pocket of the pump. I usually would recommend bleeding that air off or putting an air vent on that location. Let me see if I got a nice picture. There we go. So we've got 2 little connections right here at the top of the pump. You can see my little cursor circling around those. One is for flushing of the bearing or the seal chamber if you wanted to. In this case, it's not a hot water or anything that would require that, so internally flushing is fine. The other is you can put an air vent there. And what happens is essentially sometimes you see a pocket of air get on the top half of the pump and then water on the lower half of the pump. When it starts up, you'll know. It makes a big loud bang. You hear that big loud bang, then you know that you've probably got a big air problem in there. And I would put a little Hoffman air vent up on the top of this unit, and it'll just automatically bleed off the air as it gets in there. That way when the pump goes to start up, there's not a big violent surge of air going through there, and then water, and a big bang to go along with it. And those check valves really don't like that either, so, because they'll see a bit of air and slam open, slam close, and that's usually the big bang you're hearing. And of course, whenever you're doing service, we do put a drain plug on the bottom. Some people often miss that, and they'll go and isolate the pump and then go pull the side bits off, and huge amounts of water come out of there. So make sure that you do drain your pump, and you don't want to get all wet when you're doing your servicing. I always forget that, even myself. Sometimes I've walked up, isolated the pump. Oh, let's just pull it off here. Pant legs covered in water. So keep that in mind. You always want to drain that pump out. If you do a lot of servicing, you know, I've even had customers put a ball valve on there and run a line all the way to drain. It's not a problem to do that either. Any further questions on these things? I think the only other thing that I might mention, if you didn't want it as a little trick, you notice these slotting on the bottom of the saddle and the base here. If you were to wanting to get more room between the pump and motor, do these bolts down here as opposed to the removing the motor, because essentially this just slides this forward and back and you don't lose your alignment. So you can actually slide the motor back. In this case, it looks like it's pretty much all the way to back, but I think on yours that are out there, you'll find there's about another 6 to 10 inches of slide space, and you can slide the motor and away from the pump end, and it just gives you a little bit more room to get in there and get in front of the thing without the shaft poking you in the back of the back there. We do give some small openings here, so if you wanted to actually peel these back, you can actually inspect and see if there's water dripping out, you know, and look, see what's going on inside there. But for the most part, usually if you see water coming out, you need a new seal. It's not too difficult. Actually, this is just a vent cover to, you know, go basically on the old style pumps, you would see it, the shaft sticking out in this section. Well, on ours, since it's this cap design and we no longer have the shaft exposed, we cover it up underneath there. It's just a very short section of that shaft. We tried to shorten the shaft on these things as much as possible to have the least amount of deflection or flexing of that shaft. So we shorten the shaft, put the bearings closer together so there's less movement of that impeller inside there, because it does move a lot. I'm amazed. Big, thick 2-inch shaft going through this thing, and you can, in testing, see that shaft actually flexing a bit. So it's usually why a lot of other pumps will fail. These ones here, with as short a shaft as they are and as thick as they are, they don't get much deflection, and all the internals stay real happy for the life of the facility. Any questions? Well, if that's it, I'd like to thank you all for coming out today. If you have any further questions, I'll leave my cards and you can give me a call. I am the local guy for SouthCoast Mechanical and a few of our other contractors out here, and we do a lot of work at USC, so if there's anything you guys need, we'll be more than happy to take care of you. Thanks, gentlemen.
Okay, I'm Larry with DMG Corporation. We're the local Marley representative. I brought along Spencer. He's with the factory. He's Marley factory gentleman. He came out here just to help us out with this training. Basically, we are the manufacturer's rep. We provided the towers to SouthCoast Mechanical, and basically supported them on any problems, any issues that happen. I'll let Spencer take it away with the training.
All right, thanks, Larry. So what we're going to do today is go through a couple of the tower components for those of you who may not have been on towers much in the past, and then after that we'll dive into some maintenance features and things to consider when you're on and around these towers. So real quickly, the towers specifically that you guys received recently was this cross-flow tower on the left. As Aaron mentioned, you have an open cooling tower, and within open cooling towers you have cross-flow towers and you have counterflow towers. So cross-flow is this one on the left. That is when the air is traveling across the direction of the water. So, and I'll explain this in the components, but water is falling down the tower and air is traveling across the direction of the water travel.
You want to wear the mic or speak up?
Yeah, let's put a mic up.
Okay, I can do that.
We're gonna walk around a little bit.
Technical difficulties. We can put that in the pot.
Testing, testing. Is that good? Am I dialed in? Testing, testing. Check, 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 check. Hello, hello. Testing. And do you want me to start over or just continue?
Yeah, maybe we should.
Okay. All right. All right. Hello again. My name is Spencer. I'm with Marley Cooling Towers. Today we are going to be discussing your cooling towers that you recently received for USC. I will talk about the type of cooling tower that you have on site, along with the tower components within that cooling tower for those of you who may not be on towers very often. And then we will dive into some of the maintenance aspects of these cooling towers, things to consider. So real quickly, within open cooling tower world, there's two main types. There's cross-flow towers and there's counterflow towers. A cross-flow tower, which is the tower that you received at USC, has the direction of water traveling across the direction of air. So air comes in these air inlets here, and they travel across the water that is falling down the fill. And I'll explain what fill is in just a second. A counterflow tower is a tower that has air travel in the bottom of the tower. It travels upwards counter to the direction of the falling water. So you can literally think with your hands, air traveling up, water traveling down, counter directions. So we'll primarily be talking about maintenance on the crossflow tower, since that's what you guys recently received and that's what you'll be doing most of your work on. So within the crossflow tower, we'll run through these components here. First off, you have mechanical equipment. So your mechanical equipment is what's going to be drawing the air. This is an induced draft fan, which means there's an axial. You actually have fan blades that are drawing air through and up out of the tower. A forced draft fan, which some of you may or may not be familiar with, has a centrifugal blower that's actually pushing air up and out of the tower. Your tower is a axial induced draft fan, just like it's pictured here on the left. With your mechanical, you have your fan, you have a gear reducer, and you have your motor. Those are your three main mechanical components, and you'll be doing maintenance on all three of those. You also have your water distribution up here, and this can either be with HC valves for direct inlet, or we can pipe from the bottom of the tower or the side of the tower and have internal piping that will dump into your water distribution basins. Once the water gets in those distribution basins, we have an array of nozzles in what we call the hot water basin. The purpose of the nozzles is to properly distribute the water across the fill media, which I'll discuss in just a second. The good thing about crossflow is you have gravity-fed basins, which means that your pumps only require to get the water up into those basins. From there, gravity and the size of the nozzles that we select for your tower will properly distribute it amongst the fill. The fill here, which is this black PVC mesh-looking material, this is really where your thermal transfer is happening. So a lot of people will consider the fill it probably is the most important component within the cooling tower. Your fill is where your water comes into contact with your air, cooling the water for the purpose of the system. Now, the fill, what you'll find is when you talk about maintenance with fill, it's mostly going to be cleaning and just observing the condition of the fill. Cooling towers are known to be air scrubbers. You basically have a lot of air coming in contact with water. And in Los Angeles, we all know that the air isn't so clean out here. So these cooling towers, if they're not properly maintained, can get pretty dirty. So it's good to observe your fill every once in a while and see if it needs to be brushed or cleaned. We also have, with integral to the fill, we have louvers, which is the first point of contact for the air. The purpose of the louvers is to keep the water inside the tower. So without louvers, the water would just fall out of the fill. It may fall in the basin. It may fall out of the tower completely. So the louvers, which are connected to the fill, are angled such that water that falls on the louvers will be directed back inside the tower. On the other side of the fill, you have drift eliminators. What do you guys think the purpose of the drift eliminators is? It is to eliminate drift. That's what drift eliminators do. So yes, not get the motor wet is one purpose. But one thing that these fans are pretty powerful, and they can actually pull up some of that water that's in the system and blow it out into the air. It's not a huge problem for air quality, but really where we run into problems with drift is when you have parking near these cooling towers, or or even a doctor's office. You have doctors who have nice cars. They get little specks on their cars. They need to be cleaned. They get upset. They call us. So to avoid that, we put these drift eliminators in, which are triple pass, so that water cannot escape the tower and get outside the fan. Then at the bottom, the water will travel down the fill, get cool, and at the bottom it will reach a water collection basin, or what we call a cold water basin is another term for it. This is where you'll have a lot of your liquid level controls, and this is where the water will be pumped out to the rest of the system. So it is a pretty simple machine, but there's also a lot to consider from a maintenance standpoint. So I believe that Larry handed all of you a maintenance schedule. So these few sheets here are taken directly out of the O&M manual that you received. So I think, Larry, if you actually want to come on up here just so we can bounce back and forth, you know, things that you've seen in the field, things that I've seen in the field. I think we're going to walk through some of these maintenance procedures, and if you guys have questions, please feel free to ask. We're here for you.
Do you want to talk about the catwalk area? The inner.
Yeah. So I didn't talk about structure at all, but the main maintenance area for the crossflow towers, and you guys should be very happy that you have a crossflow tower to do maintenance on instead of a counterflow tower, because the crossflow towers have an access door right here, and from this access door you will have a plenum walkway catwalk basically. From there you'll be able to access your drift eliminators, you'll be able to access your fill, you'll be able to access your mechanical, your motors, your gear reducer. You'll be able to do a lot of your work within that mechanical access platform. With the counterflow, all the components are stacked on top of each other, so it's much more difficult to find points of entry to do maintenance. So you'll spend a lot of your time inside that maintenance access area, which actually brings me to a good point. Before we can talk about maintenance, what do we have to talk about? Safety, right? So the really most important thing with safety when it comes to cooling towers is make sure that you lock out, tag out before you do any work inside the cooling towers. These cooling towers are OSHA approved. All the maintenance guardrails we have are OSHA approved, but some consider it to be a confined space. And so make sure that you lock out, tag out before anyone enters the tower. We also recommend that you don't run water over the fill while people are in there doing maintenance. A lot of maintenance guys will kind of grumble at that and say, oh, you know, you're not gonna get hurt from water, right? But that's another precaution to keep in mind, is to not be in there when the tower's running at all, both mechanically and hydraulically. And also, to start kind of the maintenance discussion, one thing that we like to recommend to everyone is really, if you are out having eyes on the tower weekly or maybe bi-weekly, you are doing better than probably 80% of maintenance crews out there. And the reason you want to be out there regularly, even if you're not going in and, you know, really looking at the gear reducer or checking the oil level, is it will give you a gauge of what your tower's doing. You'll be able to hear it. You'll be able to see, okay, this is what the tower sounds like. Go back the next week, it sounds a little different.